Hey guys, now we're into section 1.4, which is about domain and range of a function. And so domain and range are two things that are used to describe a function that you're given. And specifically, they're used to describe the possible input values and the possible output values of that function. So we're going to use domain and range a lot in here. Anytime we're going over a specific type of function, whether it be a linear function or an exponential function, or an absolute value function, piecewise functions, we're going to do all kinds of different functions in algebra. And we will always go back to this concept of domain and range. So domain, anytime we use that word domain, we're talking about all of the possible values of the input. So basically, we're talking about all the possible x's. And we use that word possible because on a graph especially, you're not always going to see every value that is possible. And so we want to make sure that we're describing all of them using our domain, even if you can't necessarily see it all represented there. And the same thing is true about an equation. The range, anytime we refer to the range, we're going to be talking about all the possible values for the output. So remember, output is y. So we're talking about all the possible y values. So make yourself a little side note of all the x's and all the y's. I don't really know if that's supposed to have an apostrophe. We're going to go with it. So let's look at an example in A. So A gives us a function that's represented by a set of ordered pairs. So anytime you're given a set of ordered pairs or a completed table, the domain and range are super, super easy to identify because all you really have to do is look at the table or look at the ordered pairs and pick out the x's and the y's and put them in the right category. So looking at that example A, P of x is equal to 2, 3, 4, -5, 6, 0, 8, 5. We're going to list the domain and the range of those in ascending order. So start with your smallest and count up to your biggest. Even if they're not in that order in the set that's given to you, you're still supposed to write them in ascending order. And we write the set in a set of brackets, kind of like what you see out there. So for our x's, I'm going to make a bracket, and I'm just going to go ahead and warn you, I'm terrible at drawing these bracket things, so I'll just go with it. And then our x values in those ordered pairs, we have a 2, a 4, a 6, and an 8. Well, they're already in order counting up because 2 is the smallest, 4 comes next, then 6, then 8. So I'm just going to write 2, 4, 6, 8. And then I'm going to close it up with another horrible-looking bracket on the end. I've practiced and practiced writing brackets, y'all. It never gets better. So, my apologies. We'll try to fix them. Anyway, and then we do the same thing with the range. But then we're going to look at the y's instead. So, in that same ordered pair set, I have a 3, a -5, a 0, and a 5. Now, those are not already written in order, because 3 certainly is not smaller than 5 or -5 or 0. So I'm going to change the order up a little bit. Use a horrible bracket there. Smallest number out of those that I just highlighted in green is -5. Then 0. Then 3. Then 5. So that's the way that we show the domain and the range of a function that's given to us as a set of ordered pairs. Now the table, we're going to do the same way. We're going to lay out the domain by talking about all the possible input values or all the possible x values. Now this table is labeled with t and r of t, but you should remember that the t is representing the input and that r of t is going to represent your output, which means our input, our t, is going to be our domain because your input or your x values are your domain every single time. So when I look at my numbers that are there, 0, 2, 5, 8, 11, they're already in order. So I'm just going to put my little bracket, 0, 2, 5, 8, 11. Close it up. And I'm going to do my range the same way. So I have 23, 54, 66, 87, 108. They're again all in order from smallest to biggest, so I can write them in the exact order they're already in. Start with a bracket. 23, 54, 66, 87, 108. So you can use just those sets of numbers written in brackets to show domain and range if you are given the entire set of data, like an entire set of ordered pairs that represents that function, or a table that's fully complete that represents that function. Now, that's not always going to be the situation, because you could also have to tell domain and range for graphs. And that's when it gets a little bit tricky. So we're going to have to really think about how are we going to explain what these different things mean. So a couple of things you need to think about with the domain and the range of a graph is what your limits are and whether or not those things can be included. So when we talk about domain, we said we're talking about input values. So specifically, we're talking about things on the x-axis. So I'm going to look at the domain here, and I'm going to look at my x-axis. So remember, your x is this one. And I'm going to think about where on my x-axis the graph of this function exists. So if I start over here on the right side, on the left side, be helpful if I know my directions, right? So let's say I start right here on the left side. Right here. And I look at the actual graph of my function. So my function starts right here on the left, and it goes up, 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 and then down, and then up, and it stops right there. So when I look at my x-axis, the graph itself, the furthest to the left it goes on the x-axis is here. The furthest to the right it goes is here. Those are my boundary lines. Those are going to allow me to see what the domain of this function is. Those are all the possible x values for this function. So a couple of things to note, and you may remember this from when we graphed inequalities. You would have graphed them in like 6th grade and 7th grade, and we did a little bit in 8th grade. When you use an open dot to graph an inequality, that always meant that that could not be included. So it was a situation where you had a less than or a greater than symbol that did not have the equal to bar underneath it. And then if you did have a closed circle, that would indicate that that point could be included. So the way that we write our domain on things that do and don't include particular points but are graphed so everything in between is included is using something called an interval. And so this is called interval notation. And so what we have to think about is the fact that this graph exists. If I'm looking at the line that is graphed, or the whole function that's graphed, I have this and this and this. So everywhere it's consistent. There are no gaps. There's no stopping places and then starting back up places. It flows freely from all the way over here, up to here, down to here, and over to here, and then stops. So the domain are all the x values that exist from that starting point to that ending point. Not just the whole number or the integer values, but all the little fractional values and everything in between. So when we talk about the domain of that, we're going to use something called interval notation to represent everything that exists within that space. So in interval notation, you use brackets or parentheses to represent that particular range of values. And you'll use a parenthesis when you have an open dot. Let's make a note of that. Parenthesis is for open circle or open dot. And you'll use a bracket for a closed dot. Make yourself a note of that. So if you look at this, the lowest value in my domain is going to be that -4, because that's the smallest on the x that my function gets. But that -4 exists where there's an open circle. So anytime there's an open dot, I'm going to use a parenthesis, and I'm going to show -4. And then I'm going to go to the ending spot. So the largest that domain ever gets is at the 5 over here. And the 5 had a closed dot. And you can't really see it because I have stuff written on top of it, but there was a closed dot there if you could see it. And so I'm going to put a 5. and then I'm going to use a bracket to represent that closed dot. So again, I use this parenthesis here to represent the open dot that was right there. I use the bracket to represent the closed dot that was right there. These are the values that exist along the x. Now for range, we're going to think about the same thing, but now we have to look at not the x-axis, but the y-axis. So I'm going to look at the function this way instead. And I'm going to look for the lowest point and the highest point, because those are going to be the boundaries of my range. So if you look along your y-axis, the lowest the function ever goes is right here, even with the -4 on the y. The highest that function ever goes is right here, even with the +4 on the y. So my range is going to be the values between -4 and +4. Now you still have to think about parenthesis or bracket based on the kind of dots we see. So at the -4, the value of the graph that exists there has an open dot. That means for -4 in the range, I'm going to need a parenthesis. Now up here at the +4, there's not actually a dot right here, but because the graph free flows from down here, up, down, and over, and it passes through that point, we're going to consider 4 to be included. And so we're going to use a bracket. Because there's not an open dot and the line goes through that spot, it's included. If it was not going to be included, they would have intentionally put an open dot there to show that. All right, now we want to look at this quadratic. And they don't actually draw this in there, but I want you to. Add to this an arrow on both sides of this. Because if this were a true quadratic, that's what these parabola-shaped equations or functions are, quadratic functions. If this were a quadratic, then there would be arrows there to show that that continues to go on forever in that direction. So if you are looking at this and trying to decide the domain and the range, you have to consider everything that is possible, not just what you can necessarily see. So because this quadratic has no ending points, it has arrows in both directions, then we need to think about on this x-axis. Oh, I used yellow for that before. Let me go back to yellow. On this x-axis, that graph, if it were to keep going forever this way, would continue to stretch further and further outward. It would get wider and wider and wider, which means it's going to continue to stretch further and further that way and further that way. Because of that, the domain for this would be never ending. It would keep going forever. Now, mathematically, we call that infinite, right? So infinity keeps going forever and ever and ever. So to show that the domain of this would be infinite in both directions, we show a parenthesis, because you can never actually reach infinity, so it can't be included. And we show that it would go from -infinity up to +infinity. And my infinity symbols are terrible, especially with a stylus, but some people draw them like that. So you might want to make yours look cuter. Your choice. But that's what that means, infinity. Now the range, we got to think the same thing, but we're going to look at the y. Now this quadratic in the range is going to be a little bit different, because the top of it does end. It stops right here. But going downward, it would continue to go down from both sides forever, because those arrows indicate that that's what would happen. So while there is a maximum, it doesn't ever go higher than 6. It would continue going lower for infinity. So we could show this as -infinity, because it keeps going forever lower, up to 6. And because the graph touches at 6, we're going to put a bracket. So that's how we're going to look at domain and range. Parentheses when they are included, not included, brackets when they are, always parentheses on infinity. So y'all take a minute and pause this video and see if you can work these problems on this page just like the ones that we did on the last page together. When you work D add yourself some arrows so you consider that that function keeps going forever in that direction. That's going to change what you would put for your domain and your range. So pause the video. When you finish working these 4 examples, unpause it and see if you were correct. Okay, so A, when you laid out your domain and range for A was just a set of ordered pairs, which means your domain and range are given to you with explicit numbers. You need to write them all out in order from smallest to largest. So the domain for this, with my terrible ugly bracket, goes from -2, 7, 8, 11. They're already in order. -2, 7, 8, 11. Our range goes from 3, 8, 12, 21. Again, they're already in order for me. Sorry, somehow I switched the slide. 3, 8, 12, 21. Close it with a bracket. Same thing when you did B. You should have just laid out your X's in the domain, laid out your Y's in the range. The top row of the table represents the domain because it's the input. 0, 3, 6, 8, 10. Already in order, so I just put some brackets. 0, 3, 6, 8, 10. Bracket. That's not a bracket. And the range would be your Y values. So the bottom row of the table, -4, 0, 2, 15, 34. Again, still in order. So -4, 0, 2, 15, 34. So those would have just been sets of numbers written out with brackets. Now, C and D, you had to use a different type of notation because we had to be able to show everything in between 2. So you should have used that interval notation like we did on the second or the third and fourth example on the last slide. So for C, when you looked at domain, you should have looked at your X and looked to see how far that function went along your X-axis. So it went from -4 to 2. So your domain was between -4 and 2. And your dots were open on the -4 side, so you used a parenthesis, closed on the 2 side, so you use a bracket. And then you did your range the same way, but you looked at your Y-axis. So the lowest that graph ever goes is here, which is at 2. The highest it ever goes is here, which is at 8. So when I write my range down for that, I'm going to say between 2 and 8. Because on the dot that's at 2, we're closed, I'm going to put a bracket. The dot that's at 8 is open. I'm going to put a parenthesis. All right, and now D. So D, when you described your domain, hopefully you looked at your X-axis. And you looked at the fact that there were arrows continuing to go in both directions, which tells you not only does it continue to go up forever, but it would also continue to get wider forever, which means your domain is going to be from -infinity up to +infinity. My inability to draw infinity symbols just gets worse and worse. Do the best you can. All right, and then you looked at your range. And so hopefully you looked at your Y-axis. And you said, okay, the lowest point that graph reaches is here at 2. And it continues on forever upward. So your range would go from -2 up to infinity. Remember, infinity always gets a parenthesis. -2 is on the graph, part of the line, so it gets a bracket. All right, and that's an overview of domain and range.